lesson 3.6. Today we're talking about dividing a whole number by a decimal. So in the past you've learned how to divide a decimal by a whole number, and you've learned how to divide a whole number by a whole number. Well, today we're going to divide a whole number by a decimal. So that's what we're getting into today. This is lesson 3.6. Let's get started. So when might be a time that you might need to divide a whole number by a decimal? Well, we're talking about instances like, say you have a $20 bill and you want to buy so many of a certain item. Let's say you want to buy a Sharpie pen, right? If you have $20 and a Sharpie pen costs 97 cents and you want to see how many you can buy, we're going to see how many times that 97 cents will go into your $20 to see just how many Sharpie pens you could buy. So this is something that you're going to be using in the real world. A lot of times you're going to see it with money, but you'll see it with different times too. So let's go ahead and look at how we're going to do it. We're going to hopefully keep it short and sweet, and then we'll get you out of here into your quiz. Make sure you're in your PBIL section with me. We're going to go ahead and take a look at our first problem. Here's the problem. I'm going to put it up on the screen. A hiking trail is 2 kilometers long. There is a distance marker at the end of every 5 kilometers. How many markers are on the trail? So here's the problem that we are getting into to solve. And what we're looking at is a hiking trail that is 2 kilometers. And every half kilometer there is a marker. Something marking the trail, telling you that you've gone half of a kilometer. So how are we going to, that's a pretty awful decimal point. So how are we going to figure out how many markers are on the trail total? Well, to find this, I take my whole group of the thing, and I'm going to put that as my dividend. So that's inside the bracket. And now I'm going to divide that by 5/10 or 0.5 to figure out how many are on the trail all along. Now, a lot of you might be looking at this problem and just say, well, Mr. Hall, that's easy. That's going to be 4. But let's go figure out how we're going to solve this. A quick and easy shortcut that I'm going to give you for dividing a whole number by a decimal is that you do not want a decimal on the outside. You don't want it to be its divisor. So what we're going to do is, since there is a decimal in our divisor, I'm going to automatically put one in my dividend. And remember, anytime you have a whole number, it's just understood that it's going to be technically at the end of the number to the right. So what we're going to do is we want to get rid of this decimal. The technical thing that we're doing here is we're going to multiply this divisor by a power of 10. And what we have to remember is this acts just like an equal sign. So whatever we do to the outside, we have to do to the inside. We have to keep them balanced. So if I am multiplying this outside by a power of 10, my divisor, I want to multiply this by a power of 10 that's going to get rid of my decimal. If you remember, if I take 0.5 times 10, this is 10 to the power of 1, right? There's 1/10. So if I take 0.5 times 10, thinking back a few lessons, that just means that we simply have to move the decimal to the right 1, and that's going to give us a number of 5. So remember, when we're multiplying by 10, 100, or 1,000, or any numbers that's going to be a base 10 number, it's going to just move to the right when we multiply however many zeros are in that 10, 100, or 1,000. So there's 1 0 in 10, so we move it to the right 1 place. So now, since I multiplied this times 10, that means I have to multiply my inside times 10. So now, what is 2 times 10? Well, again, remember, if we're just moving the decimal 1 over, then it's going to equal 20, because we have to annex a 0. But you could probably just do 2 times 10 in your head already and get 20. So that means that we're now going to move this decimal over, and our new number is going to be 20. So now I'm just going to get rid of this decimal because I made a new number of 20. Now looking at this, I've gotten rid of this decimal and I've gotten rid of this one, or I've moved it over, right? So I can have a decimal on the inside. We've learned how to divide a decimal by a whole number. So since I have a decimal, I'm going to move it upstairs. Right? Just right off the bat, we're going to move it up. Now, can I look and solve this just like normal? Sure. Well, how many times will 5 go into 2? It cannot. But how many times can 5 go into 20? That can go in 4 times. 4 times 5 is 20. And 20 minus 20 is 0. So we're already zeroed out. So to answer this division problem that we started out with a decimal as our divisor, the answer is going to be 4. And so this is all of the math behind it. But what I want you to remember is you need to just get rid of the decimal in the divisor. And the way you do that is you move the decimal to the right pretty much just until it's gone, until it's at the end of your digits. Go ahead and flip to your guided practice section, and we'll do a few more problems just to make sure we clear everything up. Welcome to your guided practice section. We're going to solve this problem together, but first, before we solve it, what I want you to put down in your notes is which power of 10 is going to get 6/10 into a whole number. Well, remember, when we're dealing with the powers of 10, we want to see how many zeros are going to be next to 1, essentially, right? So, if we look, we need to move the decimal point 1 place to the right. So that means our power of 10 is going to be 10. It's 10 to the power of 1. So if we multiply 6/10 times 10 to the power of 1, it's going to give us 6 as a whole number. So the equivalent problem to this is going to be, because remember, we have to do what we do to the outside, we have to do to the inside. The equivalent problem is going to be 4,260 divided by 6. So let me get rid of this power of 10 here. So when we did this up top, just as a refresher, we went and found a power of 10 that's going to make this decimal a whole. We said that it was 6 times 10 to the power of 1, or times 10. So that means what we did to the outside, to the divisor, we have to do to the inside, the dividend. When we multiplied 426 times 10, we just had to add a 0, or annex a 0 in this case, and then our decimal point goes at the end. So now that we found an equivalent problem, these are going to give us the same answer. Now we can solve it since there's no decimal on the outside. We cannot solve a division problem with a decimal on the outside. So let's see what it's going to look like. 6 won't go into 4, but 6 will go into 42 7 times. 7 times 6 is 42. We're going to bring down our 6. 6 will go into 6 1 time. 6 times 6 is 8, or 6 times 1 is 6, minus 6. But remember, we're not done because we had to annex this 0. Here's our decimal point. We have to at least go until our decimal point now. So now I'm going to bring down this 0, and 6 will not go into 0. So now that I've solved all the way to my new decimal point, we can end. If I forget to go to my decimal point, then I'm saying that 6 will go into 4,260 71 times. And that's not going to be true. Because 6 will go into 4,260 710 times. So the important things to remember would be, 1, we don't want to have a decimal on the outside, so we're going to move it to the right as many times as we need. And the second thing is, once we have moved our decimal, that means we have the decimal point in a new spot. We have to solve until we get to that decimal point at least, unless there's going to be digits after, then we just have to keep going until we don't have any more digits. So, let's take a look at another problem. For number 2, we have 3/100ths as our divisor. What we need to remember is, how are we going to make 3/100ths into a whole number? Well, for this time, we need to move the decimal point 2 places. Since it's 2 places, that means that we're going 10 to the power of 2. Because what that looks like is 10 times 10, if you remember how to do exponents, and that's 100. So we essentially just multiplied 3/100ths times 100, and that gave us a 3 as our whole number. If you remember our second step, whatever we do to the outside, we have to do to the inside. So now we know our decimal point was here at the end of 216. We have to move 2 places as well. So 1, 2. We'll annex 2 zeros. And our new problem is going to be, how many times will 3 go into 21,600? These will be the same answer. So now, in order to make it easier for me, what I'm going to do is I'm going to just get rid of my original problem, because we are solving, this is our new problem. So I'm going to rewrite this so we can actually see it a little bit better. So how many times will 3 go into 21,600? We're going to need to have a little bit more space. So again, now we can just solve it like normal. But what I'm going to do this time, just so I don't forget to go all the way to my decimal point and not forget about these zeros, is I'm going to go ahead and put my decimal point up here. I can't stop until I get to my decimal point. So now we're just going to solve it like a normal long division problem. Will 3 go into 2? No. 3 goes into 21 7 times. 7 times 3 is 21. I'm going to bring down my 6. 3 will go into 6. 2 times. 2 times 3 is 6. And now I need to go all the way to my decimal point. Even though I know it's just going to be zeros, 3 will go into 0. 0 times 3, 0. And now I bring down my last 0. How many times will 3 go into 0? Is 0. So now, since if I were to annex any zeros, it would just keep being 0. I know that I can stop. We're just going to read this as a stop sign. So now I can stop at my decimal point. So 3 will go into 21,600 7,200 times. So that's our second example. Go ahead and take your quiz. Email me your score. Put that in the subject and see how you do. If this is something that was a struggle for you a little bit, go ahead and re-watch the problem that we did for our PBIL. And if the going to the powers of 10 confuses you, just remember that all you need to do is keep moving your decimal point to the right until you have a whole number. Once you've done that, don't forget to do it to the inside number, and then you will be good to solve your problem just like normal. And then go until you reach your stop sign. So thanks for watching, and I will see you in class tomorrow.